Welcome to Quadratic Solution, the platform for solution for all. If you look in our last video, we're talking about completing the square and circles, and we finished with completing the square. Now we are going to be embarking on circles. I believe when you heard of circles, something that is very circular, right? Circle with the radius and the center. That's a circle, the center and the radius. But we are going to go straight to the point. The general equation of a circle is given by x squared plus y squared plus 2g x plus 2f y plus c equals to 0. And the Cartesian equation is given by x minus x naught other squared plus y minus y naught other squared equals to r squared, where f, g, c, x naught, y naught all belong in a set of real numbers. Now we are going to talk about the center of the circle. Center of circle, which is given as I. I is defined as minus g minus f as the center of the circle. That's simply from the general equation of the circle. And for the Cartesian is given as x naught y naught, and the radius of the circle r is given as the square root of g squared plus f squared minus c, where g squared plus f squared is greater than c. Exercise: complete the square of the following. Small a at the margin: 4x squared minus 3x plus 12, and b 9a squared plus 36a plus 20. Solution: we have our a, which is 4x squared minus 3x plus 12. Now if you look, this is actually not a quadratic equation, but it's simply a quadratic expression. We describe this as a quadratic expression. It's not actually a quadratic equation, it's a quadratic expression. So we are going to learn how we can complete the square of a quadratic expression. Yeah, it's not like it's different from a quadratic equation, but there's a little bit of difference. Here we are not going to transfer the constant term because there's not equal to sign for us to transfer. So everything is going to be inside the expression, the quadratic expression. So let's start completing the square. By completing the square, we are going to make sure that we are going to factorize 4 out of the equation so that the coefficient of x squared should be 1 in order to proceed our process of completing the square. So we are going to have 4x squared minus 3 on 4x plus 12 on 4. Now we are going to simply have 4 into x squared minus 3 on 4x plus 3. Now the next part is we are simply going to add and subtract the coefficient, the half to the square of the coefficient of x. In the equation, we are going to add, then subtract. It's like adding a and subtracting a in an equation. So we are going to add and subtract at the same time. So we are simply going to have 4 into x squared minus 3 on 4x plus 3 on 8, all that squared, plus 3 minus 3 on 8, all that squared. We close. So we are adding half the square of the coefficient of x and subtracting it at the same time. So we are going to simplify our expression. So we are going to have 4 into x squared minus 3 on 4x plus 3 on 8 other squared plus 3 minus 9 on 64. Close. Now we are going to have 4 into x plus x minus 3 on 8 all that squared plus 3 minus 9 on 64. So let's simplify further. 4 into x minus 3 on 8 all that squared plus 64 times 3. We are simply going to have, we can do the rough mathematics somewhere. 64 times 3. We have 4 times 3, which is 12, and carry 1, and 3 times 6, which is 18. We add it, we have 19. So we have 192. So 192 minus 9. So we are going to have 12 minus 9 will give us 3. So we are simply going to have 183. So 183 on 64. We close our expression. Now we make sure we send our 4 inside. Now after doing the completing the square, we are going to have 4 times x minus 3 on 8 all that squared plus 4 into 183 on 64. So we are simply going to have 4 into x minus 3 on 8 all that squared plus 4 goes here one time and 4 goes into 64 16 times